Hello friends, welcome to our channel Global Tech Learn. In today's video, we will cover how we can create a data model in Power BI and what are the items we need to cover while creating a data model, such as hierarchy creation, new columns, manage relationship, filter direction, manage aggregation, hide tables or a column, how we can group the columns, and storage mode. What is data modeling? Data modeling is the process of analyzing and defining all the different data your business collects and produces, as well as the relationship between those bits of data. It is a structure of data model, how data will get stored, what would be the relationship between multiple table entities. In simple ways, it's a diagrammatical representation of how data is stored. We get data from multiple data sources. Since this data coming from different sources, there is no relationship defined between different queries. Now to make a business report, we need to define some rules how these different data tables will interact with each other. Power BI facilitates us with a model view to create modeling in Power BI itself, which further brings some more advantages. We can create data model and perform analysis by plotting visuals in the Power BI itself. We don't need to maintain two separate tools for data modeling and for analysis. In data model, by setting correct rules and relationship between tables, we get accurate data in report, and it is easy to maintain in future. With data model in a place, it further requires less maintenance. Also, as data lies within the Power BI data model itself, data security is also maintained. Power BI dataset can be further consumed by other applications via API. So correct data model will further reduce time to create data model again, and the same data model can be used by other applications to directly start the analysis. Power BI data model can be created by using star or snowflake schema by using fact and dimension table. But most popular method used for designing data model in Power BI is a star schema because of its simplicity, easy maintenance and performance. When we are getting data from enterprise data warehouses or standard applications where the modeling rules will be applied as per organization standard rules and requirement, in that case generally modeling is done by data architects, data modeler or data specialist who knows the data in its domain. Power BI developers can also do the modeling by referring to the existing source model. For example, usually in big organizations, you will find already established data warehouses like SAP BW or Oracle Data Warehouse. Other observation, when there is a custom requirement which is very specific to user or department and usually it has a small data set. In that case, data modeling usually done by Power BI developers. Let's say user have some information in a spreadsheet and they would like to have reports on top of that. Since this is a department or user specific data, it does not require enterprise level modeling and simple and basic modeling is required just to populate a particular report. Once the data is loaded from different sources in Power BI desktop, after performing all the transformations and data cleaning, we can start data modeling activity. Now let's load the data in Power BI and start preparing our data model. So I am loading data from SQL database. I'm using tables customer, date, product and sales and click on OK. Please check our videos given in the description how we can connect different data sources, perform transformation and load data in Power BI. Now we have all our queries loaded in a Power BI. In Power BI desktop, three views are available. First is a report view. In this view, we can use a different visualizations available under visualizations pane to plot the analysis. Then second is a data view. In this data view, we can see the data from different queries. Then third is a model view. In this view, we'll create a data model by creating the relationship between different queries. As you can see in the data model, After loading the queries, relationships are already established between certain queries. These relationships might not be correct or as required. So first, let's delete this relationship. Before that, we can rearrange these queries by selecting and dragging them at the required position. So I am rearranging all the queries first. Also, you can see the Power BI has already created relationship between customer and fact sale table. When you hover over this line, you can see the relationship is created between customer key and customer ID. Similarly, for the product, the relationship is created with fact sales on the base of product ID. Right click on this and select delete. We will delete these relationships and we will see how we can manually create these relationships. Again, right click on it and delete. On this model view, on the right side under data pane, all the queries which are loaded in a Power BI, the list is appearing here. When you expand this, you can see all the columns for that query. Right click on this query and various options are available which we can perform on these queries. We can add a new measure column, refresh data, manage relationship, or even we can delete this query from a model. If you want to hide this query from a report view, we want the Power BI to load the data in a data model, but we do not want to show this query while plotting the reports, so we can click the Hide in Report View option. Now in a fact sale table, if you can see, we have sales price and sold quantity columns. And we want to create additional column using these two columns as a sales amount. Select fact sales and create a new column using a sales price and sold quantity. So we can do that either by right clicking on the fact sale and select the new column option, or from the home tab we can select a new column option. So I have selected fact sale table and click on the new column option. It will open an expression window where we can write the expression to create the new column. So let's create a column sales amount, which is equals to sales price multiplied by sold quantity. When you click on this option, it will commit the code. If there is any syntax error in our code, it will also give us the error message. So suppose I am removing this bracket and then try to commit a code. So you will see at the bottom error message is coming. So let's correct this code now and again commit it. Now you can see my expression is validated and my column is also created. Go to the data view and we can see for the fact sale, sales amount column is added, which is equals to sales price multiplied by sold quantity. Now again go to the data model view. Here as you can see there is no relationship present between any of this query. Go to the report view and let's plot the analysis. On report view, from visualization pane, you can select different visuals which you want to use and perform the analysis. Let's select a simple table from this visualization. You can resize this table and replace it anywhere by dragging it. In this visual, I want to analyze customer-wise sales amount. So from the customer table, I am selecting customer name, And from the fact sales table, I am selecting sales amount. By clicking on the focus mode, we can focus on this particular visual. So let's click on this. Here you can see for each customer, same value of sales amount is coming. Now back to the report and let's create one more table. So from visualization, I am selecting table, drag it and place it beside the first table. And in this table, from sales table, let's select customer ID and sales amount. Focus mode. Let's focus on this particular table now. So here you can see it is giving me count of customers and sum of sales amount. In this visualization pane under this column tab, when you right click on the customer ID, it is showing it is giving me the count of customer ID. It is performing aggregation as a count on the customer ID as customer ID is a numeric field. But we don't want to perform any aggregation and we want to see the individual customer ID. So let's select don't summarize option. And for the sales amount, aggregation sum is selected. We can change it to any of the aggregation type which is required. If we want to see the average of sales amount, we'll select average and it will give us the average value for the sales amount. But for this analysis, we need the sum. So let's select sum. Now here you can see for individual customer ID, different sales amount value is coming. Back to the report view. Let's plot one more analysis. Again, I am selecting a table chart, expanding it. And from the customer table, I am selecting customer key and customer name column. Again on the customer key, count aggregation is applied. So let's make it as a don't summarize. So now we can see for a customer name Alexander, customer key is 1. And from the sales amount, in the first chart, we can see for the Alexander, the value is coming as 373 million. While from the sales table, the value is coming different. You can see in the sales table, for every customer, different sales amount value is coming. And it is showing the actual sales amount for each customer. And you can see the total which is coming in this table. This value is repeating in the first table where we have taken customer from the customer table and sales amount from the fact sale table. So currently it is actually showing the summary of the sales amount. Looking at the data model, there is no relationship present between the customer and the sales table. So values we are getting in the sales amount is actually a total sum of sales amount in the sales table. This is because our query does not know how to aggregate sales amount for each customer name. So it takes total sum and duplicate it for each customer. So now let's create a relationship between these two tables, customer and sales amount. Go to the data model view. Now we will create a relationship between the customer table and fact sale table. So we can see in the customer table, customer key column is there, and in the fact sale, customer ID column is there. Go to the data view and select the customer table. Here we can see in the customer table, unique customer key values are present. Whereas in fact sales, the customer IDs are repeating. Suppose here I am selecting 1. So we can see there are multiple records present for the customer ID 1. So go to the model view again, and now we will create a relationship between these two tables. So we can create a relationship either by selecting the column and drag it to the column of the second table. So suppose here the customer key, I want to make a relationship with the customer ID in the fact sale. Let me enlarge this first. Yeah. So here you can see from the customer, I want to make a relationship with the fact sale table on the basis of customer key and customer ID. So we'll simply click on the customer key and drag and place it on the customer ID of the fact sale. So now you can see the relationship is created. When you hover over this link, you can see the customer key and the customer ID columns are highlighted. Again, delete this relationship. Make sure you are dragging the column on the correct column only. If you are selecting the customer key and dragging it on the product ID, so it will make a relationship between these two tables by using the customer key and product ID, which is a wrong mapping. So again, delete this. One more way to create the relationship between two queries is by using the Manage Relationship option, which is available on the Home ribbon. So click on this Manage Relationship and select New option in the Manage Relationship window. Now select the primary table. We want the primary table as customer and we want to make a relationship with the fact sale table. See, it has automatically selected the key columns, the column customer key from customer table and customer ID from customer ID table. If you want to change it, so you can select the respective column on which basis you want to create the relationships. So I want the customer key from customer table and customer ID from the fact sale table. So select these two tables and create the relationship. Then next is the cardinality and cross filter direction. Let's keep this option as it is and also make sure to make this relationship active status on. Then click on OK. Close the window. Now you can see the relationship is created between a customer table and a fact sale table, and it is based on the columns customer key and customer ID. So again, go to the report view. Now you can see in front of Alexander, which has the customer key ID as 1. It is from the sales table. It is showing me the value 40833, which is correctly coming in this table also. This is because now the relationship is established between these two tables and Power BI knows the relationship between these two tables and how to aggregate the data, how to aggregate the sales amount data customer wise. So in this way, by creating a proper relationship between the table, we will get our correct results. Now let's go to the model view again and check what are the other options available while creating the relationship between the tables. Right click the relationship which is present between the customer and the fact sale and open the properties. Edit relationship window will open in which you can edit our relationship. Or you can select a manage relationship option, select the relationship which you want to edit and click on edit. So here you can see the cardinality option is given, which has 1 to 1, 1 to many, many to 1 and many to many. So what this cardinality means? Cardinality means number of unique values present in that column. Close this window. And here you can see on the customer side, 1 is written and on the sales side, asterisk is present. Go to the data view and select the customer table. In customer table, if you select the customer key column, you can see the unique values are present in the customer key. Whereas in the fact sale, if we select the customer ID column, you can see the IDs are repeating. Let me select customer ID 1. So you can see for a customer ID 1, multiple records are present in the fact sale. That means single customer has many records in the fact sale. So on the customer side, it is 1 and on the fact sale side, it is many. So this relationship is marked as one to many. Now let's see what is one-to-one cardinality. Let me load one more table in this. I am selecting product sales target and let's load this data. Let me rearrange this table first. So now you can see Power BI has automatically created a relationship between the product table and product sales target table based on the product ID. And here you can see the cardinality is marked as 1 to 1. Go to the data view and check again. In product table, product IDs are unique, and in product sales table also product IDs are unique. So this is a one-to-one relationship. We can maintain one-to-one relationship in Power BI data model, or instead of this we can also perform merge operation between these two queries and get the result set in the single query also. Then the next cardinality is many to many. Again, let's load one more data. Fact order. This is my fact order. Let me delete all other relationships present with this table. Now we have two tables, fact sale and fact order. In fact sale, product wise sales price is present, whereas in fact order, product wise, so I can create a relationship between these two tables based on the product ID to see the product wise sales price and product wise order price. So let's drag product ID over product ID from order table and create a relationship. So here you can see in the relationship, cardinality is marked as many to many and cross filter direction is selected as both. And here one warning message is also coming, which is giving us a warning that many to many relationship is establishing between these two tables. Click on OK. Now you can see here fact sale also contain duplicate product IDs, and in order table also multiple records are coming for the product ID. Let's check in the data. Go to the fact order and select a product ID 1. So you can see for a product ID 1, multiple records are there in the fact order table. Similarly, in the fact sale, select the product ID 1. So you can see in fact sales also multiple records are present for the product ID 1. Let's clear the filter from both the tables. So this is the many to many relationship which is created between the fact sale and fact order. Many to many relationships are not generally the best practice to follow. More commonly used relationships are one to many or one to one. In many to many relationships, we often create a bridge table using a common value, and then we use that bridge table to filter both these tables. Now again go to the manage relationships and select the relationship which we have created between the fact sale and the customer table and edit this relationship. Then there is the option of cross filter direction. In this we'll get the option for single and both. So what does this mean? Let's select single first and click on OK. And here you can see The relationship which is created between customer and the sales table, it has a single direction, which you can see it is filtering from customer to fact sale. That means if I am creating two tables, one is from customer and one is from fact sale. So this is one table in which I am having customer key from a customer table, and one more table I am adding, which is having customer ID from fact sales. So this is from customer table and this is from fact sale table. And in a data model view, we have a cross filter direction as a single, which is filtering from customer to fact sale. So how it will work? When I select any customer ID from a customer column, so you can see the fact sale table is also filtering. If I am selecting 7 here, so fact sale is also filtering to 7. If I select 12, from fact sale also I am getting customer ID as 12. So it is a single filter from customer side to sales side. Now select from sales table. Select customer ID as 3, and you can see the customer which we got from the customer tables is not filtering. This is because in this relationship we have marked cross filter direction as single. If I change and make it as a both, click on OK. Now you can see the arrow direction has changed and it is showing both side directions. Go to the report view. Now you can see if I am selecting any ID from the fact sale, it is filtering the ID from the customer side also. And if I am selecting any ID from customer table, it is filtering the sales table also. So this is how cross filter direction works. Let me keep it as single as I want to filter customers facts based on the customer from the customer table. So in case of many to many, cross filter direction is by default selected as both. So this means if you are selecting product from fact order table, it will give the corresponding result in the sales table, and if you are selecting product from the sales table, it will give the corresponding result from the order table. If you want, we can change this to single direction also. So if I am making single, so it will ask single direction from which side? Fact order side to fact sale side, or fact sale side to fact order side. So we can change the direction also from here. So now you will see it will filter from order side to sale side. Now in case of one-to-one cardinality, the cross filter direction is selected as both the sides. Right click on it and check the properties. So you will see cross filter direction is selected as both. If we want to change it to a single, it will give us the error. This filter direction you selected isn't valid for the relationship because both the sides unique records are present. So in case of one-to-one relationship, only both side cross filter direction will work. So let's delete all the tables which we have loaded to show the cardinality and which are not required for the analysis. So I am deleting product sales target table from my model by selecting the delete from model option. And also I am deleting the fact order table. Now we have created a relationship between the customer and the fact sale. Let's create a relationship with the other table also. Here you can see for the product table, product ID column is there, and in the fact sale also product ID column is there. So let's make a relationship between these two tables. So you can see it is one to many with a single cross direction. And then there is one more table, date table. So here you can see date key column is present, and here we have the sales date key column. So let's create a relationship. So now you can see the structure of our data model is like a star. The fact table at the center and all the dimensions at the corner. Now check the date table. In this table, we have date key column, date, month name, month number, quarter, weekday, weekday name and year. Let's see the data also. So we have date, date key, weekday name, month name, quarter, year, weekday and month number. Go to the report view and let's try to plot the analysis using date table. When you select a date table column and click on this expand option in front of date, you can see here automatically date hierarchy is created for this date column, which contains year, quarter, month and day. We have not manually created this hierarchy, but Power BI has automatically generated this hierarchy for this date column. This is because when you go to the file, options and setting, and under options, under current file for the data load, you can see for the time intelligence, auto date and time option is marked. So this will detect your date and it will create the hierarchy. If you uncheck this option and click on OK, so now you can see from the date table, date hierarchy is gone. So suppose for this date, we want to create a hierarchy. Again select file option, go to options and setting, and from the current file, select this time intelligence option and click on OK. So now again you can see date hierarchy is created. So let's plot the analysis showing year-wise sales amount. I have selected line chart and let's select the date hierarchy option here. So you can see all the hierarchies for that date is coming in the x-axis. And now let's select sales amount from the fact sale table. So now we can see we have yearly sales amount. And suppose if I have to see what is the quarterly data for year 2018, click on this and it will show me the result for the quarters of year 2018. So for quarter 1, if I want to see what is my sales amount for quarter 1, so click on this, so it will show me in quarter 1 month what is the sales amount. You can drill up using this option. So for this date dimension, as we have seen, the date hierarchy is automatically created by Power BI with the time intelligence option. Suppose for some other column we have to create a hierarchy. Go to the data model view and select the customer. So you can see we have a customer type and customer name. Suppose we have to do analysis of sales amount customer type. So again go to the graph. Again I am adding one page and this time I am selecting cluster column chart. In this chart, add a customer type and from sales table, let's add the sales amount. So we can see we have online customer sales amount and store customer sales amount. Further, I want to drill down and see who are the customers for online type and who are the customers for store customer type. So for that, I have to create one hierarchy here. So I can create a hierarchy by right clicking on this column, create hierarchy option is there. Or in the data model also, if you right click on the customer column, create hierarchy option is coming. Similarly, from this right side data pane also, if you right click on it, create hierarchy option is coming. So let's create a hierarchy here. So my hierarchy is created with the customer type, we can rename this hierarchy. Just rename this to customer. Now in this hierarchy to add some more columns. So with the customer type, we want to see the customer name also. So go to the customer name, right click on it, and then you will get the option add to hierarchy, and it will also provide you the name under which hierarchy you want to add this. So I am selecting customer. So now you can see with in customer hierarchy, I have customer type and customer name. Go to the report view. Here also you can see the customer hierarchy is created with customer type and customer name. So from this chart, suppose I am removing this customer type and placing customer in the x-axis. So in the chart you can see I have customer type, online and store. Now I want to drill down and see who are the customers under online type. So click on this and it will show you the name of the customers who falls under the online customer type. Drill up. Now select the store, drill down, and it will give me the list of customers, and it will show me the sales amount for the customers under store customer type. So in this way we can create a hierarchy in Power BI using the columns available for plotting the analysis, which further use for drill down and drill up purpose. Now go to the data view again. Now we will see how we can create a bucket using the column value. So suppose in this product table I have a product ID. So I am selecting the product ID, right click on it, and there is new group option. Select a new group option. Here you can give the name for the group. Suppose I am giving name as a product group. And in a group type I am selecting list. So I want all the products with the ID 1 to 5 in a one group, and I am renaming this group as group 1. And from product ID 6 to 10, I want to group these IDs under group 2. Name this as group 2. And the remaining IDs which are coming under other, I want to group them as a group 3. So click on OK. Now you can see a product group column has added, where product ID 1 to 5 is marked under group 1, product ID 6 to 10 are marked under group 2, and rest of the product IDs are marked under group 3. So in this way we can create a bucket for the product ID. This feature will be useful if you have the data like age group or a percentage group, where you have to divide the students basis on the percentage or basis on the age, and want to put them in different age group or different percentage group. Now let's go to the model view again and select a customer table. Expand this property option, and under advanced setting it will show us what type of storage mode is selected for this particular query. You can see we have loaded all the data using import mode, so import mode is selected. Even if I am selecting fact sales, it is showing the storage mode as import. For a product also, it is showing the storage mode as import. Now if you'll open this drop down, it will give me the three options: import, direct query and dual. If I want to change the import mode to direct query, it will not allow, and it will give you the message that import tables cannot be converted to direct query. If you are loading your queries using direct query or a dual mode, then you can change the storage mode for those queries to import mode. But if you are loading the queries using the import mode, you cannot change the storage mode after that. Also, if you have loaded the query using direct mode and you are changing into import mode, after that you won't be able to reverse it. That means you cannot change it to direct query mode again. So today we have seen how to create a data model by creating a relationship between different queries by selecting the cardinality and the cross-filter direction. If you find this video useful, then please do like, share and subscribe our channel Global Take Learn. Also mention in the comment section if you want us to cover any other topic related to Power BI. And we'll be back with more such learning videos. Till then, take care.